participants, including myself. And so this is enough for us to begin the class. If it's okay with everyone, we can begin the session. Okay, so because we are going to be building systems that are going to communicate on a network, it's just right that we go back to the beginning. Remember, I said that we are taking everything from scratch, looking at the basics. And so we want to begin the session by looking at some networking basics. This may serve as a refresher for some of us. And if you are new also, this is a chance for you to grab one or two. Are we all ready for the session?
Yes, please.
Yeah, we are ready.
All right. Okay, so I think talking about networks, maybe this should be a discussion instead of me just running my mouth. So what is a network? And I want this to be very brief so that we can go straight to setting up our labs. So what is a network? And I see Nimanche. Is this our Nimanche?
Pen.
Hello, Joshua.
Hello, Louis.
Are you telling us what a network is?
Network is the interconnection of devices, be it end user devices, computer systems, or servers, or anything.
Exactly. So, okay, Nanaya, your hand is raised. Nanaya. Talk to us. If you are talking, we can't hear you. All right. In order for us not to spend a lot of time on this, basically, when we say a network comprises of two or more computers that are connected either by cable or by Wi-Fi. So it can either be in a wired environment or it could be a wireless environment. And then the purpose for which networks are created is for transmission, exchanging, or sharing of data and then resources. And we build networks using hardware. So some of the basic components you may find within the hardware would be the workstations themselves. You can have the networking devices such as routers, switches, access points, and then software, which could be the operating system or business applications. These all come together to form networks. All these come together to form networks. And I'm not going to go deep into the networking bit. I just want us to just refresh our memory on some few key things. Now, basically, there isn't one simple definition for networks. Networks can also be defined based on the geographical location of the network resources. So if you find yourself in an environment where there is a network that connects computer systems just within a single building or an office space, we call it a local area network. Now, if you have an organization that has various offices across a city, let's say, for example, if you take a bank and the bank has branches within Accra, the network that links the branches in Accra together will be a metropolitan area network. Now, when the bank has branches across the country, then they will have a wide area network or a WAN. But if you have a network which is just between maybe your mobile device and then maybe your PC, you set up a hotspot, you connect your PC to your phone using a cable, you have a personal area network or private area network. Then we have a WLAN, wireless LAN. So in the event where the LAN that you have set up, instead of having a switch in the middle and then connecting cables to the computers, you rather have a wireless device in the middle and the devices are connecting to it. Then you have what we call a wireless LAN. Then we have the storage area network, which is basically a network that comprises a lot of storage devices that allows people to store huge chunks of data. Then we have this other network known as the campus area network. Now, when we say the campus area network is a network which is bigger than a LAN, but it does not reach the size of a metropolitan area network. For example, if we take the network that spans across a campus, let's say I know Game Park campus very well. Now, in as much as Game Park campus is big, it is just located in one small corner in the city called Accra, in a small suburb known as Achimota. And even Achimota is just around the Achimota Forest area there, that small area there. So that area cannot be a metropolis. So it cannot be called a metropolitan area network. But then there are a lot of office buildings that are scattered across the campus. So you can't also call it a local area network. So mostly those are what we refer to as campus area network or CAN. Then there are also sometimes you may have an organization that may have a big compound. You can call the network in that organization also a campus area network. Even if you have an organization that spans across several floors within a building, you can call it a campus area network, especially if you have multiple wireless devices that are linking the various floors together. Any question, please? Am I going too fast?
Not really.
All right, silence means I'm okay. So let's proceed. So let's look at some few terms and concepts when it comes to networks. Now, I did mention the hardware devices, talk of the routers, the switches, the computers, the servers, and then all of that. But for all of them to really work, there has to be network protocols in the middle there. Now, when we say network protocols, they are basically a set of rules that have been agreed on to determine how data is transmitted between different devices in the same network. Now, it allows connected devices to communicate with each other regardless of the differences in their internal processes, structure, or design. So for any set of devices to communicate on the network, there are protocols that have been designated to ensure that the activities that they want to transact or carry out on the network happen. For example, if I want to browse, it means that there are some web files that have been stored on a web server. And for me to access those files, there's a protocol called HTTP or HTTPS, which has the capability to display those resources in an application known as a web browser for me to view the content of the website. In the same way, if I want to send an email, there's a protocol called SMTP. And then there are others like the POP and the IMAP, and then the POP and then the IMAP. And all these protocols ensure that you can send and receive emails. The SMTP allows you to send the emails. The IMAP allows you to download the email from your email server to your email application, like the mail application on your phone, or if you are conversant with Microsoft Outlook, the Outlook on your PCs or on your phone. That's what IMAP does. There are other protocols like FTP, file transfer protocol, which is used, which allows you to upload and then download files. So there are thousands of different network protocols, but they all perform one of three actions. So some protocols allow you to communicate. For example, if you have the internet protocol, which is IP, it allows you to communicate. There are some that are for network management, like SNMP, Simple Network Management Protocol. This one allows you to manage the network. Then there are some protocols that are for security, like SSL, TLS. These ones are protocols that ensures that there is security on the network. And each of these protocols is necessary to use network devices swiftly and safely, and they work together to facilitate the usage. So at the end of the day, no matter how many devices you have on the network, the right protocols have to be in place. And from a security perspective, you have to make sure that only secure protocols are running on your system, or you have to put mechanisms in place to ensure that the protocols that you have within your environment are protected and they are secure. Any question, please? And one of the things that we are really going to be working with, and whether you're a networking person, whether you're a systems person, you're a security person, one thing that you need to be very, very conversant with is IP addresses. Now, every device communicating on a TCP network needs an identity. So the IP address is what is assigned to each device on a network so that they can communicate. Now, the IP address identifies the device's host and the location of the device on the host network. When one device sends data to another, the data includes a header. That includes the IP address of the sending device and then the IP address of the destination device. So just like our phone numbers that we use for communication, every device that communicates on a network has an IP address. And it is the IP address that tells where the device is located. So when information is sent, it goes to the location based on the IP address. And there are two main types of IP addresses. There are two main types of IP addresses. We have the IP version 4 and we have the IP version 6. I won't focus much on the IP version 6, but then we'll touch more on the IP version 4. So each device on an IP network requires 3 different pieces of information in order to correctly communicate with other devices on the network: the IP address, a subnet mask, and then a broadcast address. Normally, the IP address are written in 4 octets. So you may see a number like 198.41.12.151, and then it comes with a subnet mask 255.255.255.0. Now, every IP address is made up of 2 pieces of information. So the IP address is like the name of the computer. So just like our name, when you take anyone's name, like my name, Louis Jemfi. Now, my name contains 2 pieces of information: my surname and then my given name. My surname is Opoku Jemfi. My given name is Louis. So what this means is that if someone is trying to locate me, the person needs to find my surname. My surname tells the person where I come from, and then my given name, when the person reaches my family house and asks, okay, is this the Opoku Jemfi house? They say, yes. Okay, I'm looking for Louis. Then they point to me. So it's the same thing with the computers. So the computers also have IP addresses, and someone will say, okay, if I'm looking at this series of numbers, 198.41.12.151, how do I know which part of the IP address is the surname or the network portion, and which part is the host portion? The technology, or what we call the subnet mask, is what allows you to know which portion of the IP address belongs to the network and which portion belongs to the host. So the subnet mask tells a router how much of an IP address it should treat as the network portion. I don't know, are we all familiar with subnet masks, or do you need me to go through and then show how really it tells which portion of the IP belongs to the network? Like I said, if you are new, Just speak up, and then we will address it.
Hello, if you can kindly go through it.
All right, that is great. So, let me open a notepad. Okay. So when we say IP version 4, IP version 4 is made up of 32 bits. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. And it is in binary. When we say 32 bits, we are talking about binary. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So basically, this is how the computer interprets any IP address that you give it. Are we okay? Let me increase the font a bit. I can't find where to increase the font. Oh. Let me use zoom and see. Okay, let me go again and then zoom again. All right, so Control plus. All right, so I hope you can all see.
Yeah.
Yeah.
All right, so now every bit in the octet has what we call a decimal value.
Yes.
Are we okay? Every bit in the octet has a decimal value starting from the left side. So we have 1, 2, 8, 64, 32, 16, 8, 4, 2, 1. So when you take any IP address, this is the structure. So we have a visitor here. Yes. Bye-bye. All right. So when you take any IP address, let's bye-bye. Yes, go. All right. So when we take an IP address, let's say 192, okay, dot let's say 168.0.1. Bye-bye. All right. When we take this IP address, 192.168.0.1, and then you want to express this in binary, are we okay? The goal is that how many of these decimal values add up to 192, starting from the left side. So 128 plus 64 gives you 192. So that would be 1, 1. The rest will be 1, 2, 3, 4, 5, 6. The rest are going to be 0. I hope no one is lost. So when you take 168, 128 plus 64 is 192, which is bigger than that. But then 128 is 1, 64 is 0. And then 32 plus 128, that is 160. So 1, and then all we need is 4. So 16 and 8 are 0. 4 is 1, 2 is 0, and then 1 is 0. So 128 in binary is 101001000. Dot 0 is all zeros. And then 1 is 1, 2, 3, 4, 5, 6, 7, 1. So this is 192.168.0.1 in binary. Now, every IP address goes with a subnet mask. So, and then the subnet mask in class 4 IPs are static. Are we okay? Even though they are not always the case when the network is subnetted. But when you are taking class 4 IPs, now when I say class 4 IPs, IP addresses are subdivided into what we call classes. We have class A, class B, class C. We'll discuss this in the slide. Now, each of them has a defined subnet mask. When you take class A has a subnet mask of 255.0.0.0. What this means is that when any IP address is accompanied by this subnet mask, the first octet, which is, let's say in this case, this represents the network. Now, how is this so? When I bring this down, 255 in binary means that all the bits in the octet are 1. So we have 1, 2, 3, 4, 5, 6, 7, 8. Dot 0.0000000. Dot 0.0000000. Dot 0.0000000. All right. Now in binary, 1 and 1 is what? 1. Are we okay? So 1 and 1 is 1. Why is 1 and 1 1? Because binary is 2, right? And then 1 1 will give you 2, and that's 1. Are we okay? So 1 and 1 is 1. Again, this 2, 1 and 1 is also 1. 1 and 0 is 0. So the rest are all going to be 0. 0, 0, 0, 0, 0, 0. Dot. The rest are all going to be 0. And we've just found out that 192 in binary is what? 1 1 0 0 0 0 0 0 up to there. So it means that in this network, the network ID is what? 192. In the same case, if the subnet mask is, let's say, 255.255.0.0, what this means is that the first 2 octets are going to be representing the network ID. So in this case, we will have 192 and then 168 as the network ID. If the subnet mask is 255.255.255.0, then what this means is that the first 3 octets represent what? The network portion. So the subnet mask defines which portion of the IP address represents the network and which portion represents the host. So in that case, if you take this same IP address, this, and then give it this subnet mask, and copy the same thing here, and then give it a subnet mask of 255.0.0, and then copy the same thing again, and give it a subnet mask of 255.255.0. What this means is that even though the numbers look the same, they are on different networks. Because 255 will treat 192 as the surname. 255.255 will treat 192.168 as the surname. 255.255.255 will treat 192.168.0 as the surname. So what this means is that if this system is giving IP addresses to any computers, it will start from 1, fill this to 255, go to the 0, fill it to 255, go to the 168, fill it to 255. Now when it comes to 192.168, here it will fill here and then here. But when it comes to the one that has 3 octets being full 255, 255, 255, it will only fill the last octet. So for any computers to be on the same network, they must have the same subnet mask. That is what will tell them that they are on the same network. Please, is this clear?
Yes.
Okay, someone says that they are lost. Yes. Basby, where were you lost? You want me to start the binary again? Okay, no worries. I'll take
Yes,
the binary.
please.
All right. Who else want me to take it again?
I do.
All right. So I'll take it again. You can hear my TA in the background. Okay. So I'm going to start all over again. So what we are saying is that IP version 4 is made up of 4 octets. Octet means that you have 8 bits in each octet. Are we okay? And then each octet has a decimal value. Each bit in the octet has a decimal value, starting from 128, 64, 32, 16, 8, 4, 2, 1. So it means that this should be a dot here. Then this same thing comes again. All right. So if we are seeing that all the bits are 0, what it means is that all the bits under here are 0. Are we okay? all the bits under here are 0. Now, if you take, for example, an IP address 192.168. Let's say 100.say50. When we take this IP and we want to convert it to binary, we are going to organize it under these sets. So the rule is that how many of the decimal values in the bits can you add up to get the value of the octet? So if we have 192, 128, let me bring a calculator so that maybe people will think that I am making things up. Calculator. And then I think I can change it to, is this programmer, right? And then when I mention 192 here, you can see that the binary for 192 is 110000. Are we okay? And it is 11000 because under the 128 we have 1. Under the 64 we have 1. The rest are 0, 0, 0, 0, 0, 0. Now, what this means is that when you add 128 and 64, that gives you 192. That is why you have the 11 there. That is the rule. So if you take 168 in binary, 168 in binary is 10101 and then 3 zeros. So we have 1010100. Oh, here 1010100. And that means that they added 128, they skipped 64, then you add 32, you skip 16, and then you add the, okay, I think it's 8 that is added, because 128 plus, no, it's the 4 that is added. So they skip 32, 16 is on, they skip 8, and then 4 is added. And if you go to the calculator and you actually do, let me go back to standard and then just do 128 plus 32 plus 4. That gives you, okay, no, so it means that it's the 8 rather, not the 4. So it's 132, 128 plus 32 plus 8. Plus 8. That gives you 168. So that is what we have here. So 64 is 0, 32 is 1, 16 is 0, and then 8 is 1. But you don't have to worry yourself too much. This is not CCNA. And so it's not a big deal. But at least if you understand how the IPs are made, that is great. And then I came to say that the subnet mask help determine which portion of the IP represents the network. And that is because when you take IP address classes, we have class A, B, and then C. Class A has a subnet mask of 255.0.0.0. It's not always the case though. When subnetting occurs, this changes. Class B has 255.255.0.0. And then class C has 255.255.255.0. Are we okay? So when you take an IP address of say 192.168.100.50 with a subnet mask of 255.0.0.0. The 255 portion tells you which part of the IP represents the network. So in this case, if the IP is 255, no, we are not going to talk about subnetting, please. I don't want that trouble here for anybody. We are doing systems and all that, so no subnetting, please. You can have a different session for subnetting, but not Yeah. Everyone need to be prepared. Strike their mind that they want to do subnetting. All right, let's continue. So basically, the subnet mask is the portion of the IP address that it tells which portion of the IP address represents the network. Please, are we all clear?
Yeah.
Yes, please.
Yes.
We are all clear. Busby, are you okay? All right. And then I think, all right. So if you are good, let's proceed. So the subnet mask is used by the TCP protocol to determine whether a host is on the local subnet or on a remote host. So just as I showed in the presentation there, if you have, it is a subnet mask that tells the computers whether the system you are trying to communicate with is on the local network or it has to forward the request to the router for the router to send it outside. So when it comes to IP addresses, in order to support networks of different sizes, the authority in charge of IP addresses classified IP addresses using classes. So we have class A, B, C, D, and then E, but we will just talk about A, B, C. Class D is reserved for what we call multicasting. When we say multicasting, it means that you have a group of devices that you want to send information to. And then class E was reserved for future purposes, but it has made way for IP version 6. Now, this is because of the limitation of the IP version 4. IP version 4 has a total subnet size of 4 billion addresses, meaning that if we are supposed to give every computer in the world an IP address, we can have 4 billion addresses. But when you talk about IP version 6, some books says it's 34 on decillion, some books says it is 36 on decillion. On decillion means that there are 36 zeros after it, which is a lot of IPs. The whole world, we are about 8 billion. So it means that every device, if everyone has a computer and every computer has as A, B, and C are what are mostly used for addressing on networks. So addresses within each class has a self-identifying, they are self-identifying. When we say they are self-identifying, this is what we mean. There is a range that has been specified. Seven. 12127. So if you want to say that a certain IP is a class A address, you look at the first number that begins it. That tells you it starts from 128 to 191. 128 to 191. So if you want to know whether an address is class B address, if you look at the number that starts it and it falls within the range of 128 to 191, that is a class B address. And then if you class C address starts from 192 to 223, 192 to 2. That the number that starts it falls within the range of 192 to 223. That tells you that that is a class C address. Class D is from 224 to 239. Class D is from 224 to 239, and then class E is from 240 to 255. So these are the classes of IP addresses. And then the number of hosts they can support. So class A can support a large number of addresses, approximately 16 million addresses. And then class B can support 65,536 addresses. And then class C can support 255. Now let me show you why this is so. Remember from here, I mentioned that class A has a subnet mask of 255, right? Which means that all these octets can be assigned. Are we okay? So if you want to find the number of hosts, that would be 2 raised to the power 24. 2 raised to the power 24. Because these 3 octets, 888, that's 2 raised to the power 24. That gives you the number of IPs that you can have. Now, when you take class B has 255.255 representing the network, and so 00 here is what is representing the host. And so this is 2 raised to the power 16. 2 raised to the power 16. That will give you the number of hosts it supports. And then class C only has this portion here, 0. Therefore, it has 2 raised to the power 8. That's where you get the 255 from. It's actually 254 because you take 2 bits out. Again, I'm not talking subnetting, so I'm not going to go in there. Please, is this clear?
Yes.
Mona, the way you are saying yes for people, if you finish
Yeah,
your
it's clear.
it will come to you.
I haven't spoken today.
Okay, then there's another voice saying yes for people. All right, let's proceed. I'm guessing that is an Estina. All right, so now there are some addresses that are reserved. Are we okay? There are some addresses that are reserved. And if you look at IPv4 space, it allows us to use between 0 to 255. But some numbers or ranges have been reserved. Some numbers have been reserved. So when you take 0.0.0.0, this represents the default. This represents the default network, which is the abstract concept of just being connected to a TCP IP. So the fact that you are connected to a TCP IP means that you are connected to the 0.0.0.0. And even in routing, when you configure a router that's 0.0.0, it means you should use the default route, meaning that you should send the request to the gateway so that it will send it outside if it doesn't know where to send it. Then 255.255.255.255 is for broadcasting. This is the IP that the systems use when they want to send information that has to go to every computer on the network. So that is 255.255.255. That's the broadcast address. Now, this is not always the case. If the network is subnetted, meaning if the network is divided into smaller logical units, then every subnet will have its own broadcast address, depending on how the network is. IP, any device that has the TCP IP protocol installed automatically has this IP address. What this means is that I am there, I have an identity, but I can only use to talk to itself. And mostly when network engineers are troubleshooting a network and maybe they are not able to reach anyone and they want to test whether the TCP IP protocol is configured and it's working, they can ping the local host, or you can ping loop back, or you can ping this 127.0.0.0. Even if you're not connected to any network, this should give you a feedback. It tells the system that you're asking the system, are you there? And the system responds, yes, I am there. Then we have 169.169.254. Now this is reserved for what we call APIPA, Automatic Private IP Address. Now what APIPA does is that, you know, there is a service or a protocol known as DHCP. What DHCP does is that if you have a large environment and you are supposed to give, let's say you have about 1,000 computers, you have to give each of the computers IP address statically or manually. That is a lot of work. So there is a protocol known as DHCP, which allows you to automatically assign IP addresses to computers. For DHCP to work, you configure what we call a scope. A scope is basically a range of addresses that so you can tell the DHCP that start from 1 to maybe 100. So it will give computers IP address from 1 to 100, depending on how you define the scope. Now, if for any reason, most of the time in Windows environment, a system connects to the network, but for any reason, it's not able to reach the DHCP, it will give itself an IP address in the range of 169.254. So if you ever check your IP and you see 169.254, what it means is that the DHCP is not working, or your system was not able to reach the DHCP to get an IP address. So this is also a number that is reserved for that purpose. Any question, please? Then the next thing is private versus public IP addresses. Now, in order not to pollute the internet or the network space, we also have what we call private IP addresses. So they decided that if everyone should get an IP address, it won't be possible. It means that we in Africa won't get IP addresses. So they reserve a certain ranges and said that these are private IP addresses. You can use them in your environment anyhow you want. So they cannot be accessed from the internet because they're not visible to devices outside of your private network. So these are the ranges that have been reserved for private IPs. For class A, they reserve 10.0.0.0 to 10.255.255.255. So if you have an organization that is huge, you have millions of users, you can use the class A IP. So mostly when we are on our phone network, and then we check the IP of our phone, you will notice that it has an IP 10. It doesn't matter whether you're using MTN, Vodafone, or whatever. So long as you're using your mobile data, you're going to have an IP in the range of 10 wherever you are. Because looking at the number of users that the service providers have, that is the range that they can use. Then for class B, they reserved 172.16. This means that 172.15 is a public IP. 172.17 is a public IP, besides the 172.16. So it is not the 172 that is reserved. Let's get this. Remember, we said that class B has a subnet mask of 255.255, which means it treats the first two octets as the network ID. So 172.16. .0.0 to 172.31. Okay, so it means .17, .18, .19 up to .31 are all private IPs, but .32, 33 upwards, and then from 15, 14, 13, 12 downwards are all public IP addresses. And then for class C, they reserve the 192.168.0.0. So what this means is that if you take 192.168.1.2, they are all different networks like that. So these are private IP addresses. So most of the time, these are the IPs you are going to see in your work environment, whether it's the office or wherever you are going to see an IP like this in the local environment. Apart from these, every other IP address is a public IP, and you need to buy it. You can't just use it. The ISP has to assign it to you so that you can use it for whatever you want to use it for. Very good. Any question? So because private IPs are not reachable from outside, mostly organizations use a technology known as NAT to ensure that those computers that have private IP addresses can communicate on the public network. A moment, please. Okay, thank you, and then I'm back. So besides this, every other IP is a public IP, and you have to buy it. Any question, please? All right. Then the last thing I want to touch on when it comes to networking is the network architecture. Now, when it comes to networks, a network can either be a peer-to-peer network or it can be a client-server network. Now, in its simplest form, a peer-to-peer network is a decentralized IP network that allows very few computers to communicate amongst themselves. It's usually made up of workstations. On the network. They just have some few workstations and then they share information amongst themselves. Now, sometimes in this situation, what they do is they can designate one workstation and call it a server. But so long as it's not running a server operating system, this is not a server network. So they may designate one workstation and then make it a server, and they'll put all the things on there, and then everyone can access it. Then the main reason why I brought this here is the client-server network. Now, in the client-server network, there's a central location where things are stored. Now, one main difference between client-server and peer-to-peer has to do with the operating systems that they are running. Peer-to-peer mostly will be running client operating systems, Windows 10, Windows 11, Windows 8, Windows 7. But the server environment, they may be running server operating systems. And these server operating systems could be either Windows Server 2003, 2008, 2012, 16, 19, 22, any of these. Now, one last thing that I want to touch on is workgroups and domains. Now, the difference here is that computers on a network can be part of either a workgroup or a domain. The main difference between the workgroup and domain is how the resources are stored. So computers on a home network are usually on a workgroup, and in a Windows environment, every Windows device is by default on a default workgroup called workgroup. But you can change the workgroup name to whatever you want to call it. Then devices in the workplace are called domain. So peer-to-peer networks, we can safely say, are mostly on a workgroup. And then client-server networks are mostly in a domain. But for us to have a domain, what it means is that one or more computers are servers. And then one of those computers is designated as a domain controller. We'll talk about what a domain controller is in a bit. So to make it easy, to make changes, so everything is controlled from the central location. This makes it easy to make changes. If I want to create users, I want to change someone's password, I don't have to go computer by computer. I change the password from the central location, and then automatically everyone, the user gets the new password. There can be hundreds of computers, and they don't even necessarily have to be in the same location. If those of you that works in the bank or in the multinational organizations, you have people scattered all around the country or all around the world, and you are all within the same domain, and then you are working. Any question here? All right. If there's no question, we'll move on. So since we are going to install the server, let's talk a little bit about Windows Server. So Windows Server is an operating system, and it is installed on heavy use servers, serving as the backbone for most IT companies, applications, and services. The server handles the administrative group related to activities on a network. It organizes, stores, sends, and retrieves files from devices connected to a network. So Windows Server is an operating system. It's a software that is specially built to manage other operating system and other softwares and then other resources on a network. And when it comes to networking, Windows Server has become the standard for the last 16 years. And I think, no, now it's past that, since 2000. So the last 23 years, Microsoft has released major versions of Windows Server every 4 years and a minor version every 2 years. The minor versions can be recognized with the suffix R2. The Windows operating system is persistently updated to add new functionality to match the needs of today's users. So this is the history of Windows Server. It's come from 2000 to 2003, 2008, 2008, 2008 R2, 2012, 2016, 2019, 2022. And it's been like that. It's the same with the client operating systems. Okay? Windows 7, Windows 8, XP, Vista, Windows 8.1, Windows 10. We thought Windows 10 was the last. And then woke up one day, Microsoft brought Windows 11. So it's like that. Then we have system requirements. Now, when it comes to the Windows operating system, from Windows Server 2012 upwards, they only built it for 64-bit processors. They only built it for 64-bit processors. Unlike the predecessor, Windows Server 2012 upwards also do not support Itanium processors. So there are some systems that may have Itanium processors. These ones also are not supported. Then the following are the estimated system requirements. These are just the bare metal, the minimum. So when it comes to processor, you need a minimum of 1.4 gigahertz 64-bit processor with RAM, 512 MB or 1 gig upwards. Disk space, a minimum of 32 gig, but 32, like I said, is the minimum. Now, when it comes to the installation, you can do a clean installation, you can upgrade, you can what? Migrate also. When we say clean installation, what this means is that you are wiping the hard drive and then you are doing an installation. Upgrade means that you have an older version of the operating system, there's a new version, and then you are upgrading, but you're going to use the same box or the same system or the same hardware. Migration means that your current system does not have the required or does not meet the requirements for the new operating system. So you buy a new system, do the installation on it, then you transfer your files and services from the old system to the new system. That is migration. Any question? So that is the end of the presentation. But now, let's get busy. I hope that these things are self-explanatory, like Marty has here. All right, so I believe you are all working on your PCs. So please, let's open the VMware. All right. Let me know when we are ready so we can get started with this. Can we proceed? Please talk to me so we can proceed. Well, silence means we are ready. And Estina is now setting up a laptop. Is it that you're now installing the VMware or how? What setup are you doing?
Some of us have not been able to install. Hello, Louis, can you hear me?
Yes, I can hear you.
This is Philip. Some of us, I'm sure it appears I'm using a different system, so there's no VMware installation on it.
Hey, but we've been doing this advert in the group since the 80s.
Yeah. Well, that is what I'm saying, that I've changed my system. So the one that I installed, the VMware. But I think there is one that Microsoft uses. I'm using Windows 11. I don't know whether Microsoft have a VMware embedded in their operating
Yes,
system.
the Hyper-V is there, but it means that your operating system has to be the Pro version.
Yeah, it's a Pro version.
If your operating system is the Pro version, then you can go ahead and use the Hyper-V, but I'm not going to walk through how to set up Hyper-V here.
Okay.
If you are familiar with Hyper-V, I don't have a problem.
I've not actually used it before, though, but yeah.
It's just like the VMware. Look, no, but you let's go on, and then maybe those who want to use Hyper-V, I have some good video on YouTube. I can show you, and then you can go and follow and then set up.
Okay,
All
no
right.
problem.
Okay. Because if you say we are going to wait for us to set up Hyper-V, I'm sure the next will be you don't have the server ISO. And then all right, Raman, do you have a question?
No, please.
All right. So we are going to create our first virtual machine. And what I'm going to do, I'm going to walk through the process. We are going to encounter an error, and then we'll fix it. I'm doing this so that in the future, when you are doing it and then you encounter the error, you know what to do about it. I've encountered that error so many times. So whenever instead of trying to find a solution, I just look for a different ISO image and then I go my way. And someone brought it to my attention yesterday that the error is still there. And so I even had to set up Hyper-V yesterday. If you can see Hyper-V Manager here on my machine. I set up Hyper-V yesterday, and then I created a test system, and it was running seamlessly well on the Hyper-V. So I said, no, since I've asked people to download VMware, let's find a solution so that we fix it. So when you open your VMware and then it is new, basically to create a virtual machine is straightforward. Create a new virtual machine, just as you can see there. So we'll click create new virtual machine. We'll discuss the other tabs at the top as we go along the way. Now, most of the time, when you are creating a new virtual machine, we normally go with typical. Typical means that you will create the virtual machine using the recommended specification of the operating system that you select, and you don't have to choose a lot of things. So you can just do next, and then you are done. So we'll click next. And then I'll say install the operating system from an installer disk image. Installer disk image. So installer disk image, then you have to browse to where you put your ISO file. So this is where I have my ISO file. So I'll select it and then I'll click open. I select it, I click open, and then I go to next. So it tells me the operating system, Windows Server 2022. You can actually use any Windows Server that you have at your disposal, 2019, 2016, but you can use 2012 because I think this October, Server 2012 goes end of life. Server 2008 is already end of life. 2003 has been dead and buried so many years ago. So 2012 server, this October is the end of it. Microsoft will no longer support it. So if you are working in an organization where they are running Windows Server 2012, please draw their attention to it so that they upgrade or migrate to a different edition that is supported. All right, so we'll click next. And it's going to ask for operating system. We're not going to touch anything here. Then the next thing is the Windows Server editions. So most of the time, Microsoft Windows servers come in two editions, the standard and then the data center. The data center is for large institutions that are going to do heavy virtualization. And then the standard is for medium-sized business. And also from Server 2012, Microsoft no longer distinguishes between server editions based on features. So whatever feature the standard has, the data center has the same thing. Then the server also comes in two forms, either the core or the one with the desktop experience. You know, we like Microsoft because of the graphical user interface. But along the line, Microsoft said that some people want a light server. They don't want all the clicking and the dragging and all that. They just want to type commands and then write scripts. So they had the server core, which gave you the server, the Linux feel. So you just have the PowerShell and the command prompt, and then everything is script. But we are not going to go that way. We'll use the GUI. But again, this is going to fail, so I'm not going to worry so much. And it's going to create an account in the virtual machine using your machine name, which is fine. But then, so we'll just click next. This is going to fail. You can decide to just watch this for now. And then it says that you did not enter a product key. Yes, that's fine. So I'm just going to call this test because I know it's going to fail. If it succeeds to, then lucky us. Then you can decide to split the virtual disk into multiple files, or you can store it as a single file. Mostly I prefer to store it as a single file so that when you are moving it, it becomes easy. You can just copy it, even though all of them are going to be in a folder, but as a single file, it's very easy to move it around. And 60 gig of hard drive space, yes, that's okay. But don't worry, it's not going to take 60 gig of your drive. It normally uses what we call dynamically expanding drive. So it will create the drive using a very small size, and then as you use it and you go along the way, it increases the size for you and go up to 60 gig. Then we'll click next. So if you look here, it's showing you where it's going to store the virtual machine, and then the hard disk size, the RAM, it's giving it 2 gig, and then the network adapter type is NAT. Remember yesterday I said we are going to use NAT as our network adapter because we want our virtual machine to communicate with our network. So please make sure your physical machine has a network access. Or for starters, you can leave it like that, but as you go along the way, you will need to have the NAT enabled so that it can communicate over the network. So I'm going to click finish, and it will create the virtual machine. So basically, this is how you create a virtual machine in VMware. So I'm going to watch this go, and then we'll see how it goes. So that is the error there. Windows cannot find the Windows Server license, what. So if we go along and you try to install, this is the error you are going to get. So I'm going to close this, and I'm going to delete the test machine. And then we will go through how we can really fix this. So I'm just going to remove. You say this will not delete the virtual machine from the disk, but yes, I've removed it. If you want to delete the virtual machine, when you go to documents, you see virtual machine, and then you can just delete, and then it's gone. All right, so now we are going to do proper installation. So new virtual machine, this time instead of typical, we'll go to custom. And we are going to define the parameters ourselves. So I'll click next. And the first thing is I want you to use the VMware Workstation version 17. You can drop it down if you want it to behave like it is VMware 16, or you want it to behave like it's EXI, you can do that. But I want it to be VMware Workstation 17. Then we click next. Now, instead of choosing the installer disk image, we will say, I will install the operating system later. You say, I will install the operating system later. So you select this. What this means is that we will, after creating the machine, this will be like going to town and then buying a computer. Then you come and either plug a USB or a CD to format it. So we say we'll install the operating system later. Then we'll click next. So we want to install Microsoft Windows, and the operating system is Windows Server 2022. So this, you leave it as such. We click next. So we will call this DC1. So this is going to be the name of our first virtual machine, DC1, where DC means domain controller. And then we'll click next. So it's asking us the firmware type. Now, most modern computers use UEFI. So we are going to use UEFI. We are not going to use the traditional BIOS system. We're going to use UEFI. And then you click next. Oh, Rosalind, I think you can use the 16. It should work fine. This should work fine. I think it will work. All right. So here you can specify the number of processors. So I'm going to give my system 2 processors. That is okay. So our server is a dual core server. Then we'll click next. Then the RAM, you want to do 4 gig RAM. You want to do 4 gig RAM. So we will select the 4 gig RAM and then click next. So the network type, again, you can use the host bridge networking. It gives the guest operating system direct access to an external Ethernet network. The guest must have an IP on it. Or you can use network, the NATed network. It gives the guest and operating system access to the host computer's dial-up or external Ethernet network connection using the host's IP address. Then we have the host-only networking. We can also have host-only networking. Host-only networking will allow only your machine to have their private network that they will use for communication. So we can actually even do the bridge, but that will mean that it will connect directly to our network, which is also okay. So we can go the bridge type, or we can also use the NAT. But let's go with the NAT. Then we'll click next. Then the next thing is the hard drive I/O ports. So we are going to use this very one, the recommended one, because we are not using a server. If we're using a server, then we can select the SCSI type, but then we are not using a server. This is a desktop or a laptop that we are using. So we just maintain this and click next. And the hard drive, depending on the type of hard drive you have in your machine, my system is a SSD, and so it's using the NVMe, which is the SSD standard. If your machine has an HDD, you may have to select SATA, depending on the hard drive you have in your machine. Then we'll click next. So because this is a new installation, you want to create a new virtual hard disk. You want to create a new virtual hard disk. So we'll click next. And then you will store the virtual hard disk as a single file, and then it should be 60. Or we can say it should allocate the 60 gig at once, but we don't want that. We don't want that because we may be running a server that will not necessarily be using all the 60 gig. But if we leave it like that, it will take 60 gig of our space, and then we may not be using it. Then we'll click next. So it's going to create a virtual hard drive for dc1.vmdk, which is the extension for VMware disk files. And then we'll click next. So once we have all these in place, we just click finish. We just click finish. So when you click finish, it gives you the specs of your machine right here. It tells you the RAM, the processor, the storage, the CD drives. Right now it's on auto detect, the network type. But remember that we did not put in a CD drive. So before we power on the machine, we go to edit virtual machine. Edit virtual machine settings. So here you can edit the settings of your virtual machine. If the memory is too small, you can add more. If you want to increase the processor, you can add more. If you want to increase the hard drive, you can add more. But our business here is with the DVD. We can also add extra resources. We can decide to add a hard drive. We can decide to add another CD-ROM. We can add another network adapter. We can add a USB controller. You can add more, just like when you buy a server or a desktop, there are slots where you can put in extra resources. It's the same thing as a virtual machine that you are creating. All right, so I'm just going to cancel out because I don't need this. And then the CD-ROM, I'm going to select use ISO image file, click browse, and then go to my documents where I have my ISO image, and then I put it in. I click OK. And now our virtual machine is ready to be powered on. So you can just power on your virtual machine from here. So you notice that at first, this didn't come. That was where we got the error. So from here, it's just like installing a new operating system. So I just click next. And then select install now. Okay. Now, please pay attention here. We are going to install the Windows Server 2022 standard evaluation, but we will install the one with the desktop experience. If you select the first one, you are going to end up installing the core version. When Microsoft first introduced this, you could switch between the server core and then the desktop by installing some features. But from Server 2016, you can't switch. So it means that if you make or you forget and you install the core, you have to delete it and do the installation again. So please and please, again, make sure you select the one with the desktop experience. Then you click next. So whether we like it or not, we have to accept the license terms. So let's accept it and then click next. Remember, I told you that you can do clean installation, you can do upgrade and migration, but you cannot upgrade the machine from here. If you want to upgrade, you need to first be in the operating system before you can upgrade. But for first installation, you always go with a custom install. That is where you get to do the clean installation. So you select custom install. And then we have the storage drive here. I'm just going to click next. I'm not going to go to new and then create the partitions and all that. We're not really going to change anything. So just click next. All right, so it will take some time for the installation to be done. So let's just sit back, let the installation finish, and then we'll continue. But whilst the installation is going on, if you have a question, you can ask. Okay, Rahman. Yes, there are some few certifications out there. Microsoft has introduced what we call the hybrid server administrator examination, which is an exam that you can take. Oh, And even I think that one is just one exam. Let me check. Hybrid server administration. There's an exam. So you can take that one. And so what that exam focuses on is you are looking at managing users in the Active Directory environment and then managing users in the cloud using the Azure Active Directory and then the other tools that comes with the Windows Server. And the other tool that comes with the Windows Server. So this is it. So Microsoft Certified Windows Server Hybrid Administrator Associate. But I think one thing that you have to know is that now all Microsoft certifications are required to be renewed on a yearly basis. So every Microsoft exam that you write, each year you have to renew the certification, but you don't necessarily have to rewrite the exam. There are some training courses that you do online, and then after that, you
Luis is gone.
I think my network, but I'm back. Let me see if I can log in and then just. So each time your certificate expire, they will send you an email to let you know that your certificate is about to expire. And I think I even have one certificate that is about to expire, and I will have to log in, do some few minutes of learning, or you can just go straight forward and take the certification. The reason for the yearly expiration is due to the fact that the cloud is evolving. The cloud is static like the previous server environment, where even if you do MCSE 2003, you will be able to do server administration. Now it's not like that. Because the cloud is evolving, it's basically means that things are going to change. And so you also need to abreast yourself with the new changes. That is why those certificates expire on a yearly basis. It's made the certification quite annoying, especially those of us who were into the Microsoft environment. I mean, to do certification on a yearly basis now is just a bit annoying, but actually, that is it. So you can do that exam. But I think the MS 101 expiring, if my memory serves me right. If not, you can also do those ones for management purposes. Any further questions? So this is my Microsoft profile. And when you take the exam, you get your profile like that. But these days, I'm concentrating more on the security aspect of things. Let's check on the installation if it's done. Okay, so I think the installation is done. And when the installation is done, you are required to set a password for your administrator account. Please let me know when your installations are done, then I can proceed. That's if anyone is doing the installation, or maybe you are going through the class and later you sit down and then do your installation, that's fine. But if you are going through the installation, please let me know whether the installation is done or not. Hello, Pa. Good evening. A moment. Mami Adumola. Okay, so Rahman, let me know when it's done. How many of us are show by hand if you are going through the installation right now? Okay, so I think we have only Rahman going through the installation. But please, like I mentioned earlier on, the rest of the session is going to be dependent on what we are doing now. And so if the next session, if you don't have the installation done, it means that you are going to keep owing. So let's try our best and then come up to speed so that we can all move together. So let's give Rahman, what's the percentage?
It's 96%.
All right, so let's give you 2 minutes. It should be done, and then we will pick up. Rosalind, you have to download the server ISO. The link was put in the group. So try and then download it. When you download it, and you also download the VMware, then you can use it for the exercise. You have both, then what's the issue? Or you want to finish the session, then you go and do it later.
So, Luis, I want to, after the session, I'll go through the recording once again, then I'll use it to install. I was thinking what we were installing was the Windows Server ISO, Windows 10 ISO. I downloaded the Windows Server ISO and left the Windows ISO. That's what I've just downloaded. So once the class is over, I'll do it before I return to bed.
Okay, that's fine. Hey, so I was muted. So what I was saying is that we are supposed to choose a password, and the password has to be a complex password. If it is not complex, the system will not accept it. And also, please don't forget your password when you set the password, because if you forget your password, you have to delete your virtual machine and do it again. Very, very simple. All right. So I'm going to put a password of my system. And then I will click finish. So just like every other Windows system, here we are. Now in the VMware, you are required to press Control or Delete, but when you press Control or Delete, it will take effect on your physical system. So in VMware, instead of Control or Delete, we use Control Alt Insert. So when you look on your keyboard, you can see Insert there. Or when you look here on the top of the VMware tab, you can see we have this icon there. That is also Control or Delete. So you can either select this, or you can do Control Alt Insert on the keyboard, and you can enter your user credentials. So this is my administrator password. This is the logon screen of the server, just like a Windows 10. There's nothing special here. So what I'm going to do is I'm going to pause the class here, but before I do, we are going to clone. Hey, why are these ladies laughing at me? Because I was muted and I spoke. No worries. So I'm going to turn off the virtual machine. Remember, in our infrastructure, we are going to have 2 servers. So I'm going to turn off this virtual machine. We are going to clone it so we don't have to go through the installation process to get the second server ready. So I'm going to power off the virtual machine. So when you come to the top here, you can see this tab here. When you drop down, there are a lot of options. We have shut down guest, suspend guest, restart, or power off. So we want to shut down. Power off is like if it's a physical machine, you are pressing the power button to kill the power. So we just shut down guest, and then we'll shut down. So that at least those who are yet to do the installation won't be missing, so they can do their installation, and then God willing, tomorrow we will all pick up from where we left off. So from here, I'm going to clone the virtual machine. To do that is very simple. You right click on it, and then, so those of us who were asking of the snapshots, you can see that the snapshot is here. When you right click on it, you can take a snapshot, or you can go to the snapshot manager and then specify how frequently the snapshots should be what? Taken. Are we okay? So I'm going to close this for now. Right click this again, manage, and then select clone. So when you come to clone, you say this result will help you create a copy of this virtual machine. If you intend for other users to create clones from this virtual machine, grammar. So I'm going to click next. And I want to clone the current state. I'll be okay as it is now. So I'll click next. But I don't want to create a linked clone. I want to create a full clone. Linked clone means that it will always require the original to be there. Are we okay? It will always require the original to be there. So I don't need that. So I'll rather create a full clone. I'll create a full clone. So I'll click next. So I'm going to call this one DC2. I'm going to call this one DC2. And then we'll click finish. So give it a little time, depending on the speed of your machine. It should be done in no time. All right, so I click close. And there it is. So I have another virtual machine, DC2. If you have any questions, let's have them. If there are no questions, we are done for today. And I know it has been a marathon, but I'm sure Olympio, please, you have to upload the video after it's done so that we can have access to it. Okay?
Yeah, I'll be charging £10 each.
But maybe I want to in the pounds or this or bag and I know about this. Why?
Oh, may I'll upload it. I'll upload it.
Okay, Ernestina, so taking a snapshot is not necessarily like cloning, because the way clone is the file type and the kind of files that it takes is different. So it's not necessarily like the same thing, even though you are going to get copies of the virtual machine. Hey, you didn't hear me, eh?
No.
Yeah,
I
we didn't
said
hear
if there are no further questions, then we'll call it an evening. God willing,
Okay,
tomorrow
okay,
pick up
okay.
and then we take off.
Okay,
All
okay,
right,
okay.
So
sure.
have a good evening.
Okay. All
Thank
right,
you.
thank you.
Bye.
Thank you.